Got to give the people with a gray beard, get the people what they want.
Hey, sorry.
Mr. Hakan, come on in. It's all good. I'm working. You can make it happen. All right, today we're talking about Gema tables in factored form. So go ahead and get that down if you can. So we've learned about vertex form. Vertex form shows the vertex in the equation, but now we're going to talk about factored form. So it's another way to show a quadratic equation, and factored form shows you the x-intercepts in the equation. All right? So let's take this basic factored form equation. This is what a factored form is going to look like. Now notice you don't see x squared in this situation, but if I was to actually factor these and multiply these out, this x times x would make the x squared. So x squared is there, you just don't see it because it's been factored out, all right? But if I'm looking at this, I'm like, oh, this is factored form. This is telling me my two x-intercepts. So my x-intercepts in this equation, just like we saw in that vertex form when they're inside this parentheses, one is going to be -3, 0. And the other x-intercept is going to be 7, 0. Right? And remember, usually when you see, these intercepts or vertexes hidden inside the parentheses, it's always kind of the opposite of what's inside of here. Okay? So I already know that if I was drawing this parabola, this one happens to be concave up, I would have an x-intercept at -3, and I'd have an x-intercept at 7, and I already know this thing is concave up. So it looks something like this. I don't know exactly where the vertex is, but I know it looks something like that, okay? So now, what I want to do is I'm going to make a Gema table to figure out more information. Now the way that I do these Gema tables, the idea is the same, but they work a little bit differently. So let's just go right here. So let's make a pretty basic looking Gema table, right? And as always, I start with x. But here's where it's different. I'm going to show the creation of both of these. So here, I'm going to have x plus 3. And here, I'm going to have x minus 7. And in this next one, I'm going to show where x plus 3 is multiplied with x minus 7. That's happening right here. And finally, I'm going to show where 2 is multiplied with all of that. 2 times x plus 3 times x minus 7. So that's how I build this type of Gema table. And I know this is going here and here. This is where these two things are being multiplied. And this one right here is where it's times 2. Now, remember when we were trying to show the symmetry in vertex form and we would start with the vertex in the middle? Well, this one, we don't know the vertex. We don't know where the middle was. But we do know the ends. We know the x-intercepts. We know the outsides. So we're going to start with the x-intercepts on the outside, these values. So I know one of them is at -3. And then, trust me on this one, it's going to help you. I'm going to count all the way to the 7. So I got -2, -1, 0, 1, 2, 3, 4, 5, 6, and 7. So I see my two intercepts. And the reason why this is important because I'll find my vertex in the middle. Okay? So now I'm going to start to fill these out. I'm going to start with this -3. Well, -3 plus 3 is 0. -3 minus 7 is -10. I have to multiply these two. 0 times -10 is 0. And 0 times 2 is 0, right? -3, 0, and x-intercept. That's what I want. I'm going to do the same thing with this other one. And this is the key. This -3 is what makes this a 0. Over here for the 7, well, 7 plus 3 is 10. 7 minus 7 is 0. There's that 0 that I need. 10 times 0 is 0. And 0 times 2 is 0. I found my two x-intercepts. Now, I'm going to figure out where my vertex is just from using this. Well, what do I know about the vertex? Well, I know that the vertex is literally the middle in between the two intercepts. So, I really take these and I count off. Going 1, going 1, going 1, going 1, right here is your vertex, okay? And in this situation, I can actually now just run it through. Okay, so 2 plus 3 is 5. 2 minus 7 is negative 5. 5 times negative 5 is negative 25. And negative 25 times 2 is negative 50. There's my vertex, 2, negative 50. So this would be the point 2, negative 50, which makes sense with this. Obviously that is not to scale, but that's how it goes. And now I've shown my vertex, I've shown both x-intercepts. If I wanted to find a y-intercept, I could figure it out from here. I just make x is 0 and work backwards. But the main things we're probably going to look for in this one is vertex and both x-intercepts. So there you have it, okay? This is factored form. We're going to do one more. I know they got an eraser. We're going to do one more in this form, and that is it. Hopefully this video is not longer than 10 minutes, and I don't think that it will be. Okay? So let's look at something that's more similar to where you have to actually create the equation. So I'm working through this thing quick. So let's look over here. And let's say, well, what if I give you, actually I'm not going to make it creative now, but I'm going to say, well, what if I give you this situation? I know that you have the points, we have y equals negative 3 times x plus 6 times x plus 2. Okay? I want you to show me the vertex and the xy intercept, or the x-intercepts. You're going to make a Gema table. Try to do it before I do it. Actually pause it and try to do it right now. If I was going to do it, I'd look at this and I'd say, okay, well I know my x-intercepts are negative 6, 0, and I know my x-intercept is negative 2, 0. Cool. So I'm there. Okay. I see that I'm going to create this. And I'm going to say here is x. Here is x plus 6. Here's the x plus 2 part. Here's where x plus 6 and x plus 2 are being multiplied against each other. And here where all of that is being multiplied with, what is that, negative 3, x plus 6, x plus 2. Okay? I built it. I see x goes into each of these individually. These two get multiplied together here. Everything gets multiplied by negative 3 right there. Okay? Now again, I want to set up my counting for my intercepts. So it goes from negative 6 to negative 2. So I'm going to start here. I'm going to call this negative 6, negative 5, negative 4, negative 3, negative 2. If I want to know where my vertex is, N1, 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 right here, ends up being my vertex. This better end up being a 0 here. This better end up being a 0 here. Negative 6 plus 6 is 0. Negative 6 plus 2 is negative 4. 0 times negative 4. This one times this one is 0. 0 times 3 is 0. Lovely. Negative 2 plus 6 is 4. Negative 2 plus 2 is 0. That's what I want. That's 0. 0 times 4 is 0. And 0 times negative 3 is 0. Cool. That's what I wanted. And now if I want to find my vertex, I know it's at this point because it is the direct middle between both of my intercepts. Negative 4 plus 6, what is that? 2? Yeah, negative 4 plus 6 is 2. Negative 4 plus 2 is negative 2. Is that right? Negative 4, 6, 2. Negative 4 plus 2 is negative 2. Yeah. Negative 2 times positive 2 is negative 4. And negative 4 times negative 3 is positive 12. And I'm just gonna double check that. That is right. So now, x-intercepts, vertex right here. I just made my Gema table in factored form. That's what I got, guys. That's where it is. I'm gonna be done. I think you all are gonna be able to pick this up pretty quickly. Actually, you should be in good shape. I don't have any shout outs lined up, so I'm just gonna give a shout out. I'm gonna give a shout out to my twins. To my twins, Emmeline, shout out to Emmeline and Mirabella. Shout out to you as well. I've had the pleasure of having one of you last year and one of you this year, and you're both lovely and doing great. So, shout out to you all for continuing to hold it down. Shout out to everybody for coming back after this long break and being engaged and making it happen. We're going to keep it moving. Good work, y'all.